So quiz 8. First, let's label the carbons 1, 2, 3, 4, 5. Looking for HNMR signals. So there's, draw some of those H's in. Always helpful. So this one can get kind of tricky. So 1, that'd be A. 2, B. C. D. E. And F. Now remember, D and E are different because, right, they can't rotate about between the pi bond between 4 and 5. So E is always on the cis to the OH. So those are always on the same side. So these are actually end up being different. Also, so that hopefully that makes some sense. And then the predicted frequencies. So if we look at our table, you will see, hopefully. So A is that aldehyde CH. That should be, I don't know, 11 ppm. Should be high. B is in that allylic region. So what is that? Like that's 2.5 to 1.5. C is also in that allylic region, 2.5 to 1.5. All right, don't need to be specific, right? Because C is next to this pi bond. B is next to that pi bond. Let's see, D is vinyl. So unlike allylic, D and E are both actually attached to the carbon that has a pi bond. So that is 6.5 to 4.5, I believe. That's that vinylic region, vinyl region. E, same thing. And then F, it's, who knows? They come and go. Sometimes you don't see them at all, but it's not a big deal. Yeah, either way. And then 5 IR frequencies. Can we do 5 IR frequencies, you think? What can we do? So first thing I look for is the OH. So we have an OH stretch. So that's 3,300. What kind of CHs do I have? I have SP3. So that's 2,900. I have SP2. So that's 3,100. I even have an aldehyde CH. Look at this. So the aldehyde CH, and that's 2820 and 2720. What else do I have? I have a C-do-bond-O for the aldehyde. So I don't know where that was at. That's at like 1705 maybe. I have an alkene stretch. That's at like 1600, I think. Yeah. Oh, I have a di, and I also even have a di-substituted terminal alkene, and that is at, let's see, what was that one at? Di-substituted terminal was 890. So just asking for 5. You can find a bunch. They're there. Yeah, this one could have been, really is 12 to 9. I just put 11 just for guessing. Yeah, so these are all approximates.
Oh.
All approximates. That's a good point though, right? So D and E are different, but their ranges are the same, right? Like B and C are different, but their ranges are the same. But so it's gonna be a separate peak probably within this range. That's what we're saying here. All right, it's gonna be separate peaks within this range. Let's do number 1. How many proton and carbon signals would you expect from the molecule below? Label them and then include predicted frequencies for the C NMR ones. Okay. So here we have some H's. Got a little bit of symmetry in this molecule. Not a lot. 3 there. So I'm seeing A, B, C, D, E, and F. So how many types of hydrogen is that? That is 1, 2, 3, 4, 5, 6. So I expect 6 peaks for the HNMR. For carbon, I'm going to expect more. I see 1, 2, So A, B, both of these guys are C. Both of these guys are D, E, F, G, H, and I. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 peaks for C13 NMR. And then the ranges are going to be basically pretty similar. But again, they're just ranges. So I'd have to take my table out and take a look here. What am I looking for? I'm looking for the table with the carbon NMRs. So A, I'm going to say is around 50 to 0. B, C, and D are all 150 to 100. Let's see, F is probably 50 to 100, or 50 to 0, sorry. G is higher up. G is going to be 200 to 150. H and I are also going to be that 50 to 0 range. So that's all I'm looking for there for those kind of things. Whoops, I screwed this up. F should be 100 to 50. Sorry, because this is the carbon bonded to an oxygen. My bad. That's what F should be.